Okay, we go to example number 2, where we are given a definite integral, and we know that the value for this definite integral is 36. Our question is to find the value of a, which you can see it is in the lower limit here. So the idea is we need to do this integration, which is from a to 3, 3x squared plus 2x dx, and we need to make it equal to 36. So the first step, I will find this integration in terms of course of a, and then I will find the value for the a. Now, if we do this integration, we should find the antiderivative, and we should write here is the antiderivative, which means the integral, the usual integral of this function. Now, the integral of 3x squared, it will be 3x power 3 divided by 3, so we get cancelled, so we just leave it with x cubed, plus this one would be 2x squared divided by 2, which would be just x squared. So here we have x cubed plus x squared equal 36. One time we need to substitute 3, and one time we need to substitute a. So we have it like this, minus, we substitute a, which is a cubed plus a squared equal to 36. Now, if we substitute 3, we'll get 27 plus 9, which is basically 36, minus the other bracket, which has a. I need to find the value for the a, equal to 36. Let me go to the next page. What I will end up with is negative a cubed plus a squared equal 36 minus 36, which means I will get 0 here, and here I will get a cubed plus a squared. Now I can take a squared as common factor, so I get a plus 1 equal to 0. And this has two solutions here. Either a is equal to 0, and that's the first option to me, or I have a plus 1 equal to 0, which means a equal to negative 1. That's the second one. So those are the two answers that we get from this question. Let me just repeat what I did. The first step, I just write the integral as is without any changes, equal to 36. Next, I find the integral of 3x squared, get it x cubed, 2x, I get it x squared. Next, I substitute 3. So when we substitute 3, you will get 36. 36 with 36 get cancelled, so this one equal to 0. Now, a cubed plus a squared, you take a squared times a plus 1. Two numbers multiply with each other equal to 0, means the first number is equal to 0, which means a equal to 0, or the second bracket is equal to 0, which means a equal to negative 1. Let me do another example similar to this one. That's example number 3. So in example number 3, which is almost exactly the same, but here we will use the power rule or the shortcut of the power rule. Remember, the shortcut of the power rule, if you have u power n and then you have u prime, it's just add 1 to the power and divide by the new power. You get this answer. So in this question, we have integral from a to 2, and then we have x plus 1 square dx equal to 18. Now we need to find the antiderivative, the integral of x plus 1 power 2, but you can notice that this, I can call it u, and then you have u prime here, which is already equal to 1. We don't write it down. So all what you need to do is you add 1 to the power, you get 3, and then you divide by 3. And that's what you will get. Of course, you write it down as is. The answer is equal to 18. Now we substitute, of course, the bottom number. We get a plus 1 power 3 divided by 3. And we substitute 2. Now, if we substitute 2, we will get 9 equal to 18. Take 18 to the other side. So we get minus a plus 1 power 3 divided by 3 equal to 9. Why equal to 9? If you take 9 to the other side, it will be negative 9. 18 negative 9 is just 9. That's how we do it. Next step, I will multiply everything by negative 3. Why? Because 3 and negative will get cancelled. So on the left, I will have a plus 1 power 3 equal negative 27. Now, how do I get from a plus 1 power 3 equal negative 27? What we will do next, we will take the cubic root. So we have a plus 1 power 3 equal to negative 27. Of course, cubic root with a cube, we get just a plus 1 equal. Cubic root of negative 27, this is just negative 3. So a will be just equal to negative 4. And that's the answer for this question, which is similar to the previous one. And that's what we get. Next, we will do properties of definite integral. Now, one of the properties that we already know, if you focus with me with number 1, if there is a number in front of the function, what can we do with this number? Take it outside. So take this number, do outside, and just find the integral of the function. Similar thing, if we have a plus, the integral will be distributed. So we get the integral of the first one and the integral of the second one. So we get this plus this. We have seen this before, the integral from a to a, number to itself, the answer is 0. If you want to switch a and b, of course you can do that, switch them, but there is a tax that you need to pay, which is negative in front of the integral. Number 5, which is the most important one, if you have integral from a to b directly, you can break it down from a to c, and then from c to b. It's like there is a direct way and there is a transit way. There is a way where we have to stop at some point, which we call it here c. That's one of the things that we want to keep in mind while we do the integration. Next is we want to use those properties in this example here, which is example number 4. If you look at this example, you can notice that we are given the integral from 0 to 2 for f equal to 3. I don't know what is f, but I know that the integral is just 3. I have the integral from 0 to 2, which is for the g equal to 2, and I'm looking to find the integral of 4f plus g. Now remember what I just said. I said that the integral will be the integral of first plus integral of second. That's the first step, if we want to do it step by step. So the first thing, I'll distribute the integral. Next step, we take 4 to the other outside. So 4 integral 0 to 2 f of x dx plus integral 0 to 2 g of x dx. Now the answer is 4 times plus something. It will be just 4 times 3 plus 2. So the answer is just 14. And that's how we find the integral. Take the number, it's like you can even do it in a shortcut. Just take the number outside and the plus. So this would be 3 plus 2, which is 14. Example number 5 is given to me by this. In the given, I have three information. Integral from 1 to 5 for f of x equal to 3. Integral from 1 to 3 for f of x equal to 1. Integral from 1 to 3 for h of x equal to 5. What do I need to find? I need to find the first question. Now, if we look at the first question, we can see that this minus 2, I can just take it outside. So it would be negative 2 integral from 1 to 5 for f of x dx. Now, what is the integral from 1 to 5? 1 to 5, this is 1 to 5, f of x, the answer is 3. So here would just become negative 2 times 3 equal negative 6. Question part B, just take the integral of first plus integral of second. So you'll do the integral from 1 to 3 for f of x dx plus integral from 1 to 3 h of x dx. Integral plus integral, it would be 1 plus 5, the answer is 6. Question number 3, I can do it directly. Take the 2, take the 5 outside, and here write the value for the integral, which is 1, 5. The final answer will be just negative 23. Question number 4, I don't have integral from 5 to 1. I need to switch them. The formula said yes, you can switch them, but there is a minus you need to put. And now if you switch them, the answer is 3, so we get negative 3. Let me do 7. 7, I have number to itself, so the answer directly is 0. For number 6, you need again to switch them. So it would be h of x minus f of x dx, which means negative 5 minus 1, the answer is negative 4. So we did 7, 6, 4, 3, 2, 1. The remaining part is, let's do number 5, which it needs a little bit of work to do number 5 here. Okay, for number 5, I need to find the integral from 3 to 5. What actually I have, let me just draw something that will help you always visualize what's going on. I have the integral from 1 to 5, which is the very big integral, equal to 3. How do I know this? From the first one. So I will represent it like something in this way. Integral from 1 to 5 equal to 3. However, I also have the integral from 1 to 3 here. I know this integral equal to 1. You ask yourself, how much is the remaining integral? And that's exactly what we are looking for, which is the integral from 3 to 5 f of x dx, and the answer will be just 3 minus 1. Why 3? Because 3 is the long integral from 1 to 5 in one stretch, and 1 is the integral from 1 to 3. And the answer is, of course, 2. And that's how we find the integral of only this part of the question. Finally, we'll go to example number 6, which will be about finding the integral from 0 to 4. Well, we have to focus here, because how can we find the integral from 0 to 4 in one stretch? I don't have the function f of x. Unfortunately, I don't have any function called f of x. So, I have the function from 2 to 6 given by this. I have the function which is less than 2 given by this, but I don't have it from 0 to 4 directly. So the idea here is to split it out. So if you have integral from 0 to 4, maybe we can do it from 0 to 2, and then do it from 2 to 4. We always said that this is possible to us to stop at any point we would like. Now you ask yourself, why do I stop at x equal to 2? Because at 2 is where the function changes from the first one to the second one. So that's where we will choose it up here. And that's the integral here from 0 to 2. Now what is f of x? F of x will be for x plus 2 dx. What is the other one? The other one is 3x squared minus 2 dx. We have those two integrals, we need to do them directly. This is equal integral. The first one will be the integral from 0 to 2. It will be 2x squared plus 2x. The second integral will be just x cubed minus 2x. And then we just need to substitute 2. So if we substitute 2, we get 12 plus, we substitute 4 here. So we get 64 minus 8, 56, minus, we substitute 2 here, which will be 8 minus 4, just 4. And that's the answer here. The answer is 64.